In this next video, we're going to go over the first group exercise in Chapter 5, creating a constrained component curve. The first step is to open up the plan, j2p0200.dgn file, which we have already. The next step is we're going to select the Create Template icon in the Corridor Modeling Task Tools. And so we're going to go over to our Civil Tools. We're going to slide down to Corridor Modeling. And the tool that we need to select is this one right here, Create Template. Once the file opens up, it opens up to our MoDOT library. And so what we need to do is we need to save this MoDOT library to our local project location so that we can edit this file. Because right now, since we're pulling from the MoDOT library off the T drive, it's not going to let us modify this library. And so we're going to create a template library that is just for this project, and we can go in and edit the template, the library. And so to do that, we're just going to do a file, save as, and in here we need to define the folder location where we want to save this off to. And so we're going to be under District CAD, Design, Randolph, J2P0200. We're down in Chapter 5, Data. For the file name, we're going to call it the J2P0200.itl. Once you type it once, go ahead and copy it and then paste in the file name area. Once you have everything set up like so, we're just going to go ahead and hit save to that. And now if you look in the path up here, you should have it out to your local project location. And once it's out there, you can edit this library however you like. Now what we're going to do is we're going to create a folder location for the component that we're going to create. And so I'm going to go ahead and close down my templates. I'm going to go up to the very top of the library pathing here. I'm going to right click and do a new folder. I'm going to call it J2P0200. And typically we tell all the users to do this. If you just created a new ITL for your project, first thing you need to do is create a folder so that you can go into that folder and you can copy templates, copy components, copy end conditions down to this location, and you can edit them in this location. Typically, we don't recommend editing the items up in the MoDOT library section, but we do recommend copying those items down to this folder location and then editing them however you like. So what that does is it leaves the MoDOT library intact, and then you can know which templates have been modified and which ones have not. And so under this J2P0200, we're also going to create a folder called Components. And then under that, we're going to create a folder called Curve. And this is where we're going to create this curve component for this exercise. Now within the curve folder, we're going to create a new template called curve. So on the curve folder, I think I got an extra character in my curve name here. In this folder here, we're going to do a new template. And what a new template does is it creates a blank area where we can create a new item, whether it's an end condition, a component, or a template. And so for this new template, we're going to call it curve. And to help us create this curve, we're going to check our dynamic settings, and those dynamic settings are located right here on this icon right next to the left arrow. If I open those up, I'll have this dialog box pop up, and it's called Dynamic Settings. And what we want to do is we want to set the step increment to be 0.1, 0.1. Like so. And what this does is it allows when we place items, it will jump every 1/10 of a foot in the X and same thing in the Y. Right. If not toggled on in step 7, it says turn on display point names. So we're going to make sure that display point names is turned on. That's right here. So when we store a point, we'll be able to see that point name. Right click on the current template window and select add new component constraint. So we're just going to come out in this blank area here. We're going to right click, add new component, and we're going to do constraint. On page 518 you'll see the curb detail that we're going to try to store. And in step number 9, we're going to set up the component name as concrete curb. So we're going to come down here, we're going to type in concrete curb. We're going to give it a feature of excess curb surface. Next, set up the dynamic settings as follows. For the point name, we're going to use shoulder. And there are some predefined point names in here if we go to the down arrow, but these are all MoDOT standards, and this exercise that we're doing is a Bentley exercise, and so the shoulder name is not in there, so we're just going to go ahead and use shoulder, or type in shoulder and use it. For the point style, we're going to use excess curb surface. And for the precision input, we're going to use XY, which is just an XY coordinate. And for that XY coordinate, we're going to start this curb surface point at 0, 0. Once you have it in there, all you have to do is hit enter to that, and you can see that my curb surface is starting to draw. Now note, below step number 10, the notes that we have there, it says the default units for precision input are in feet. You can enter units such with the proper specifications, such as 6 inches, where you would use this number 6 with the inch symbol, and you can also just type in 0.5. Watch the prompts in the lower left corner of the Create Template dialog. They basically guide you as what the next step is. When creating a component using precision key-ins, an escape will allow you to go back one step. And so we got the shoulder point there. Now we're going to move on to the top of curve point, and that's going to be step number 11. So on step number 11, it wants us to put in the point name. So again, I'm going to go back to my dynamic settings and type in TOC for top of curve. Point style is going to remain the same. Apply affixes is going to be turned off. And we'll talk more about affixes later on when we put templates together. For the precision input, we're going to keep it at XY, and we're going to type in 0.7, 0.07, comma 0.5. Once I have that typed in, I'm going to hit enter, and you can see that my curb top point has been placed. Now we're going to work on the back of curb point, the BOC point. And again, so what we need to do is we need to go back to our dynamic settings. We're going to type in BOC for back of curb. Again, the style is the same. Affixes is disabled. And we're going to go down to our precision input. And this time we're going to, instead of using XY, we're going to use an H sub S, which is a horizontal distance and slope. And so the horizontal distance is going to be 5.5 inches with the inch symbol, comma 0 for the slope. Once I have that entered, I'm going to hit enter, and you can see that the top of, or my back of curb point has been drawn. Now we're going to slide down and do the back of curb bottom point. So I'm going to go back to my precision or my dynamic settings. I'm going to type in BOC bottom. Style is going to be the same. Affixes is off. This one, we're going to use a DL for our precision input. And DL is the delta distance from the last point stored. So we're going to go 0 in the X, comma, negative 16 inches with the inch symbol. And we're going to hit enter to that. Now we're going to store the top of curve bottom point. So we're going to go back to our dynamic settings, TOC underscore BOT for the name. Point style and apply fixes is the same. Again, we're going to use a DL option, which is the delta distance from the last point stored. And it's going to be a negative 7.75 with the inch symbol, comma 0 for the Y. Once I have that entered, I'm going to go ahead and once I type that in, I'm going to hit the enter key to store that point. And at this point in time, we are done plotting all the points of the curve. So all you have to do is right click and do a finish. What some users like to do is they like to do a fit view, so their curve looks just like everyone else. One thing you just have to get used to with this program is it will distort the picture to fit it into the view as best it can. But it is drawn to scale, and you can zoom out and zoom in if you need to. You can also distort the scale by holding the shift key down or the control key and scroll. Once we have that curve stored, we can go ahead and do a file save to save it to our template library. And so that's all there is to plot or creating a curve component, and this finishes the first exercise in Chapter 5.